Metastability in digital logic and design refers to an unstable equilibrium state in digital circuits. This is a state where the output cannot settle to a valid logic level. Metastability is generally caused by two reasons. The first reason is setup time violation. This happens when data changes too close to the clock edge, violating minimum setup requirements. The second reason is hold time violation. This occurs when data changes too soon after the clock edge, violating minimum hold requirements. When a circuit enters a metastable state, the output remains at an intermediate voltage between VDD, which is the high voltage level, and VSS, which is the low voltage level, for an unpredictable duration. It is neither a definite high nor a definite low. Metastable states resolve with exponential probability over time. The probability p as a function of time t is given by the formula p of t equals e to the power of minus t divided by tau. A synchronizer is a circuit designed to minimize metastability when crossing clock domains. The basic structure of a synchronizer involves passing the signal through two flip-flops. The input D goes to flip-flop 1, which then goes to flip-flop 2, and then to the synchronized output. Here is the Verilog implementation of a two-stage synchronizer. Always at the positive edge of the clock, the first flip-flop, FF1, takes the asynchronous input, async in. The second flip-flop, FF2, takes the output of the first flip-flop, FF1. Finally, the synchronized output, sync out, is assigned the value of the second flip-flop, FF2. MTBF stands for mean time between failures. It is a statistical measure of synchronizer reliability. The formula for MTBF is as follows. MTBF equals e to the power of tr divided by tau, all divided by the product of FCLK, FData, and K. Here are some design guidelines to keep in mind. First, use dedicated flip-flops with minimum logic delay in the synchronizer path. Second, allow sufficient time between synchronizer stages for metastability resolution. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.